In this video, we are going to discuss about the coordinate geometry. Coordinate geometry we have studied in our previous classes. In this video, we are going to see some of the applications of coordinate geometry. Like what are the applications of coordinate geometry? In coordinate geometry, basically there are two coordinates. The first is x and the other is y. Right? So if there are 2 points, it is at distance 3 and it is at distance 4, right? You can easily calculate the right? If they are single dimensional, right, you can easily calculate the distance, right? The distance between them is 1 centimeter. If it is 3 centimeter, right, if it is 3 and it's 4, the distance between them is 1 centimeter. This was all if you are having only one dimensional points, right? What if you are having two dimensional point? We have studied about two dimensional. It has x-axis as well as the y-axis. So if you are having two dimensional structures, right, it is for coordinate geometry we know there are two dimensionals, right? This one is y and this one is x, and there are 2 points, right? If this is P and it is having coordinates as 1, x1 and y1, right? And similarly you are having Q. It is having two coordinates, right? x2 and y2. So if these are the 2 points on the coordinate plane, right? So this is known as the coordinate plane, okay, Cartesian plane, because we are having x and y's. Okay, on this plane if you are having 2 points, it is having x as well as the y. So now this is a basic formula to calculate the distance. What the distance says is it is a difference of x2 minus x1, right? It's squared. Why it is squared? Because distance can never be negative, so we have to take the square. Okay, so we take the square and then we have y2 minus y1 whole square. Okay, now by squaring, what does this mean? You have to take the difference and you have to square, because the distance can never be negative. So you don't have to just memorize it, you have to understand the concept that you have to take the square and then you have to do the under root, because we want the distance to be always positive. Similarly, if this distance, right, you have to calculate the distance. This is the origin, right? The coordinates of origin are 0 and 0, we know that. So if you have to calculate the distance of P and the origin, now for origin these coordinates are 0, right? If you take this as origin, right, sorry, okay, then cos sum x and y will be 0. Now you can say for distance between the origin and a point, you can directly write it as x square plus y square, right? And you can calculate the distance, because origin is always having the coordinates as 0 and 0, right? Now let us move forward and understand the other formulation. This chapter is more oriented to formulas. If you understand these formulas, this chapter is very simpler one, because by just putting the values you get the answers, right? If the coordinates of P, which, okay, now this is, see the third point, right? What it says, if you are having, okay, this is y and this is x. If you are having 2 points, right, if you are having 2 points, it says the 2 points as A and B. There are 2 points, it's x1 y1 and it is x2 and y2, right? Now if I say there is a point P, it lies somewhere on this line segment, right? It lies somewhere on this line segment AB. Let it be P. Okay. So this P, we don't know the coordinates of this P. Now how you will calculate this coordinate? If you know this P divides this line into ratio M1 and M2, right? This is the ratio. If you know the ratio M1 and M2, then you can easily calculate the coordinates. Okay, what I am calculating coordinates of P. We don't know the coordinates of P, then I can just calculate the coordinates of P by using this formula. What it says, M1 x2. Okay, you have to take M1 x2 cross, right, plus M2 x1 again cross. You have to take the crosses, and addition, just addition of these two. Similarly for y also, M1 y2 M2 y1. You just have to cross. Okay, you have to understand that these are in cross. Okay, and divide it with M1 plus M2 by using just visualizing that there is a cross formation in the formulation. You can remember this formula, like M2 y1, you have to take M2 y1, you have to take M1 y2. Okay, you have to take the cross forms, right? So this was about this formula. Now if you have to calculate the midpoint of the line segment, right? If you have to calculate the midpoint, like what is going to be the midpoint of this line segment, it's very simple. How we calculate the mid? We just add the two and divide it with, add the two coordinates and divide it with 2. Similarly, x1 plus x2 divide with 2, because mid is always calculated using this only. Okay, y1 plus y2 divide with 2. So this is very simpler one, right? You have to just add the two coordinates and divide it with 2. Now the last one says, if you are having a triangle formulation, right? See, this all, okay, there is x-axis, there is y-axis, and you have a triangular formulation. If it says it's x1 y1, right, it is x2 y2, right, it says x3 and y3. What you will do, how you will calculate the area of this triangle? This triangle is A, B and C. Now to calculate the area, it's very simple, right? It says half. Okay, first you have to take x1 and you have to take the coordinates other than y. Okay, y1, you have to take y2 minus y3, right? You have to take the other two except y1, right? Next you take x2. Now if you take x2, you have to just forget this y2. You have to take the other two. It says y3 and y1. For x3, you have to forget about the y3. Okay, there is no y3 if you write x2. There will be y1 minus y2. Okay, so if, see, in this formula you have to understand there is 1, 2 and 3, right? There is all 1, 2 and 3. It is 1, 2, 3. Again here it is 1, 2, 3. It's 2 here, so you have to take 3 and 1. Here you are having 2, you have to take 1. Sorry, it is 3, right? x3. Because 3 is skipped, na? So here will be x3. It would be x3. So if you have 3 here, it will be 1 and 2. So you have to just remember that you have to take x1, x2, x3, and then you have to write the other values of y except the one which is written here. Okay, so this is the formula for finding the area of triangle. This completes your coordinate geometry, because this chapter is not about coordinate geometry, it is about the application of coordinate geometry. By knowing the coordinate geometry, you can find the areas of triangle, you can calculate the coordinates which are dividing the two line segments and all. Thank you for watching.